Hey, what is up? It is Thursday, May 5th, 2022. Yeah, and welcome to Chef the Algo Man / Coding with Chef. Yeah, still deciding between the two. Yeah, if you have a preference, just let me know. Either way, by the time that you probably decide whether your preference is one or the other, I'll have probably come to a decision myself and have made the changes accordingly to the channel. Either way, let's get to it. It's a lovely day outside, and it's time for an algorithm because of that. No, it's just because it's good practice, gets my blood flowing. And today we have a good algorithm problem, a classic one, and one that really, I think, helps people who interview in FANGs and who like those tricky algo problems to kind of like work at their really cool algo chops. I don't know what that means. Whatever. All I know, it's the classic problem, and let's get to it. It's 340 longest substring with at most k distinct characters. By the way, if you like my videos, like, subscribe, comment, and check out the discussion that I have. I write the discussion up pretty thoroughly for every problem, even if they've been written up before. It gets helps me practice, helps me understand the intricacies of the problem, and it's just good multifactorial learning to do that, to write down the actual explanation and discuss it as well, like I'm doing here. This is listed as a medium problem. That's because it's got the CS hook to it. I'm gonna like this problem, and it says, given a string s and a integer k, return the length of the longest substring s that contains at most k distinct characters. Okay, so the problem statement looks simple, right? Let's go through the examples, and that'll elucidate what it's asking for. So the input is ECEBA, right? And k equals 2, so you're past k, and the output is 3. The substring is ECE with length 3. Okay, so there is a longest substring that has k distinct characters at most. So E has, let's say, look at the substring one string at a time. E has one character, C has one character, EC has two distinct characters, right? ECE also has two distinct characters, right? The distinct characters are E and C still. ECEB has three distinct characters, right? Because B, E, and C are distinct in this substring. So this substring here, ECB, falls outside that length of the longest substring with most k distinct characters. So what do we do at this point, right? Because if we keep increasing the size of the window, ECEBA, we're just going to keep getting longer and longer strings, and we won't be able to necessarily tell if there's a longer substring because we're just adding more non-distinct characters. So what we do at this point here, when we've violated this condition, we start to contract this window, right? So we have ECEB. Then the next substring we looked at is CEB, that still has 3, right? And then we contract the window again. We look at EB, that has 2, and we already found one with 2. That was, we found 2 strings with 2, which were EC and ECE, right? So EB isn't the longest substring with 2 distinct characters. What we do is, at this point, since we are less than or equal to the 2 distinct character requirement here, we can expand the window again. And once we expand the window, EBA, we have 3 distinct characters. Okay, so that violates the condition K. So at the end of the day, this ECE was the only substring with at most 2 distinct characters. Okay, AA and the value of K is 1. So A is equal to 1. Let's start one character at a time. From on the right side of our window, right, we have A is equal to 1. And so A has at most 1 distinct character, but AA also has at most 1 distinct character, because even though there's 2 characters, A and A, they're the same character, and that same character is the 1 distinct character. All right, let's look at another example real quick. B, C, E, ace, B, A, C, A, and let's say K is equal to 3. Okay, so we start first A, then we start, so A is 1. A is 1 distinct character. AC is 2 distinct characters, right? ACE equals 3 distinct characters, right? So at this point, right, we've hit 3 distinct characters, and we now can check what's the longest string. So the longest string with 3 distinct characters at this point is 3. So the next string, ACEB, has 4 distinct characters. So then we start to contract the window again. CEB equals 3 distinct characters, right? And now we, you notice we're alternating between expanding the window, right pointer, and contracting the left pointer. So CEB, and we all do it based on what this K value is. So CEB, and let's turn this to A to elucidate, to E. Okay, so CEBE equals, so that's still equal to 3 distinct characters, right? But this is the longest substring now because there's 4 characters total. Longest. So this is the tricky thing to realize, okay? You're always trying to find the longest substring here, and so the next, we're still under K is equal to 3. So since we're still at the number of distinct characters equal to 3, we CEBEC, and we're still at K is equal to 3, and now this is the longest, right? The distinct character is still equal to 3. And so we keep, since we're still not violating the K condition, CEBECA, and we still have, now we violated the condition. Okay, and this is because now we have 4 distinct characters, and therefore at this point we start to contract. Right, we're at the end of the string, so we have EBECA, and at this point we have 4. And the next, so we contract the window again. We have EBECA, and we have 4 distinct characters still, and we have ECA. Okay. Now we have this point. We have 3 distinct characters. Okay, and yeah, but at this point, there's no point in continuing on the loop because we've already gotten to the. We've already found the longest string. Okay, so that's roughly how the algorithm works, right? We're contracting the left and right pointers of this window that we were creating. So let's go on with that. So we'll start with int. Remember I said we have a left and a right window. So left equals 0. Int right equals 0. Int longest equals 0. Okay, because we're trying, the whole point is to get the longest value, right? The longest pointer. So okay, and the longest string rather. And now, how do we work with the strings? Okay, that's not too bad. We'll use a map. Distinct equals hash map. Okay, now that we're going to increase the size of this map. This is just going to be a frequency count map, and decrease the size accordingly. So, well, right is less than s length. So now we're going to loop through our string. right? And we're going to push the right pointer to the right. And if now, as we loop through the string, we'll have two conditions. We'll have a condition to check whether we're less than or equal to the number of distinct characters specified by k. Okay. And again, it's at most. That's why I have this less than or equal to, because you can have a substring that's less than k, right? And that could, we're still comparing the longest there, as long as the size of the distinct, the number of distinct keys in the map, which is the number of distinct characters in the set, is less than or equal to k. So if that's the case, what we do is we get the character at the rightmost value. Okay. Now we're going to increase our frequency map by reusing our default. Python is much nicer when it comes to adding keys to a dictionary, but what can you do? We just decided we made our bed with Java. So this is just, we are adding to this distinct map, and then we push the right pointer ahead. Now, if we violate our condition, if distinct, that size, or if we rather maintain our condition, right, then we compare the longest string at this point. Longest equals math.max, right, minus left. Here you go. This is the important thing. We need to compare the longest string again at this point. And if we violated our condition, and then we don't do anything here, and then the next part of the loop will take care of the rest of that. Now, this is in the case that we are no longer we have more than k distinct characters. Distinct, but left. Now we remove the character from the left, and this is again, since it's a map, left car 0 minus 1. That's how we remove a character. We remove the left character, so that's what we're doing in our example. We're shrinking this left character here. And then, if, again, on the technicality of the map data structure here, if we happen to have the value of the key less than or equal to 0, then we just need to remove that key from the map, and that'll make sure that when we're using the size function, it counts the correct number of keys in the map and doesn't leave the zombie key going there, because here we're subtracting -1, right? So we don't want to get this again, we don't want to have like a zombie key thing happen. Okay. Okay, so this looks right, and then at this point, return longest. Okay, great. And run it again. Let's see what we did wrong. Remove left car. Let's see. We must have right car. There we go. Okay. All right. So this is how you shrink and expand this window. Now this is an efficient solution compared to the brute force solution, which would be checking every substring. We don't want to check every substring, because that would be at least n squared, right? This is a linear time algorithm with a linear space. Because of this map here, right, in the number of characters. So that's it. Yeah, so if you like this video, like, subscribe, and all that good stuff, and let me know what you think. I have a discussion thread which I'm going to post, and yeah, we'll see you around.